Hi all, welcome to Geeks for Geeks. I am Utkarsh Kesarwani, your GFG instructor, and today we are going to solve the today's problem of the day, which is sum of all substrings of a number. So let's solve this question. Yeah. So the question is saying that given an integer s represented as a string, the task is to get the sum of all possible substrings of this string. The number may have leading zeros. It is guaranteed that the total sum will fit within a 32-bit signed integer. So the question is saying that you have been given a string s. You have to find out all the substrings of this s and then add them. This you have to return. Hope the question is clear now. So let's try with one example. Let the example is 4 to 1. So what they are saying, create all the substrings from this string. So let's see the substrings. It started from this 4. So 4, 1, 4, 2, 4 to 1. These are the substrings which we can create from 4 only. Then for this 2, 2, 2, 1. And for this 1, 1. Now if I will add them all, so what it will be? 4, 2, 6, 1, 7 here. In this line we have 2, 1, 3, 4, 2, 6. And here we have 421. If I will add them all, 10, 1, 11, 1 here, 6, 2, 8, 1, 9, and 4. So 491. This is the answer which we have to return. Okay, 421. So how we can do the brute force approach is simple. Just find out all the substrings. Find all the substrings and add them. Simple. So let's first solve by this approach, the brute force approach. Let's code it. So I will first find out the size of the string. So n is equal to s dot size. For the finding the substring, you know that we have to run O of n square loop for this. So we will run two loops. For I is equal to 0, I should be less than n, I plus plus. First loop, C. 421, we have to find out all the substrings. What I will do, I will start my I pointer from 0 index and traverse it to the end of the array. Whenever I will be at I start my j pointer from this I position and traverse to the right side. So what will happen when j at this ith index, 4 will come. When I will increase this j to next index, so now my value will be 4 2. So 4 was originally, I will add 4 2. Then I will increase my j and 1 will be added. So 4 to 1 it will become. Then I will add 4 to 1. Now I will increase my ith index and now again start j from here. This question you have already done because it is a basic substring question. So I am writing the code. Yeah, for int j is equal to I, j should be less than n and j plus plus. Now we have to create a temp variable for storing the current string we have. What I will do, since we have to return answer in int format and it is given in string format, so what I will do, first of all I will add the current number to my temp variable. So temp plus is equal to s of I minus of 0. So it will give me the number, int number. Okay, and after finding this I will add this temp in my answer. So I also have to create an answer variable here, and after that my temp is equal to temp into 10. Why this? See, when you were at this 4 4, 2, 1. Your I was here, your j was here. So your term will be equal to this 4 first time. Okay. Now you will add this 4 in your answer. Now when you will increase this j index now, so you want the value 42 now. If you just simply add 2 to it, it will give you 6. That's why what we are doing, we are multiplying it this 4 by 10. So it will multiply by 10 and then we will add 2, so it will become 42. Correct? So that's why I have multiplied by 10 here. In the last we will return answer. Let's see this. Yeah, here j will be there. Let's submit it. It has been submitted, but this solution is, how much time it is taking? It is taking O of n square time. Here we the size of the string is only till 9, that's why it is not giving TLE, but the solution is running in O of n square because you are saying that here we have two loops. But this solution is O of n square solution. We have to come up with more optimized solution. So see the optimized solution for this question. We have number as 4, 2, 1. Since we are finding all the substrings and adding them, and in all the substrings we have the numbers from this 4, 2 or 1. Okay, so if I will be able to calculate the contribution of each of these individual numbers, then we can do it in O of n time. See how. If I will ask you uh, only for contribution of this 1, so what I will do, I will see in how many substrings this one is coming. Okay, so this one can only come as single. This one can come with 2, 1, and this one can come with 4, 2, 1. Or let me write it more better way. So 1, 2, 1, 4, 2, 1. So you are seeing that the contribution of 1 is always at the ones place. And how many times it is? It is 3 times. So we can say it is 3 times, and always 1 is at 10 to the power 0 place, means ones place. Also from this you can see that for including this 1, what we can do, we can take this only, or take this only. Since there are no numbers on the right, so 1 will always be in the last in the substring, and if any number is in the last, so it is at the 10 to the power 0 value or base. Okay, let's see the contribution for this 2. So if I will start making the substrings from this 2, so we can make 2, 2, 1. So these are the substrings which we can make starting with this 2 and going to the right side. If I will try to make the substrings in the right further, so 2 will not be included. That's why every substrings will start from 2 for its right side value. And when we will make the substrings on the left side, then this 2 can also come. So it can come in 42. This 2 is also coming. Okay. Yeah. So what here you are seeing that you have 2 at zeros place. So you have 2 into 2 to the 10 to the power 0. You have 2 number of 2's at 2 to the power 0, and since the value is 2, so it will also be multiplied by 2 now. I am talking about this 2. So 2 here, 4. So it is at 10 to the power 0. If I will talk about the base is 10, and the value we have here is 10 to the power 0 into 2, correct? And 2 times it is coming, that's why 2 here, plus 1 times 2 is coming at tens place. So 1 time it is coming at tens place. So 10 to the power 1, and which is coming? 2 is coming. Correct? If I will talk about this 4, so for this 4, since there is no left side value, so all the substrings which have 4, they will always start from 4. So it can be 4, it can be 4 2, it can be 4 2 1. So one time it is coming at zeros place, one time it is coming at tens place, and one time it is coming as 100 place. So one time it is coming at 10 to the 10 to the power 0 place, and value is 4, plus 1 times it is coming at 10 to the power 1 place, value is 4, and one time it is coming at 10 to the power 2th place with value 4. So are you observing some pattern here? For any number 2, let's suppose 2, we can make, if I will see the right side, so 2 will come like this, or 2 will come like this. So means it is once coming in zeros place, once coming in tens place. So it is 22. The contribution of 2 for right side will be 22, 2 here and 20 here, because it is as the 10 place. If I will see the contribution when we will make the substrings from the left side, so what will happen? We can make this, or we can make this. Correct? Similarly, if there was some more number, so we can make this, we can make this. So 2 will always come with any number on the left side, once at the tens place and once at the 0th place. Because when we will take only till this place, so it will be at 0th place, and when I will take at this place, so this 2 will come to tens place. So what I am seeing here, that the number of digits it have after it, suppose we are counting the contribution of 2, so I will see how many places are here. Here 2 places. So 2 places means 22 is the contribution. 1 it is coming for itself like this, and similarly the number of digits we have in the left, the number of digits we have that number of times 22, because if I will see from the left, so it was once 42, once it was 4 2 1. If let's suppose, so it is coming once at zeros place, once at tens place. If suppose there was 5 in front of it, so it was like that 5 4 2, 5 4 2 1. So once at 0 place, once at ones place. So that the number of element we have on the left count into what? Once at 0 place, once at tens place, means 22. Or we can just write simply 2 into 1 1, or 2 into 10 to the power 0 plus 10 to the power 1. 2 was the R number at that place. So here we will write that the value at that index, and the next one is value of 10 to the power 0 cumulative. What I have told you, let's just again say it. 4 2 1. So what I am saying, if I am saying let's first of all write the values in 10 to the power basis, what it will contain. So it will be 10 to the power 0, it is 10 to the power 1's place, it is 10 to the power 2's place. So it means it is 100 place, it is 10th place, it is 1th place. Okay. So for each number contribution we have already seen that if this 2 was in the 10th So please, so our value was this. If this 4 was at the 100 place, so our value was 444. Here you can see 444. So it means I have to do cumulative here, because when I will see the contribution, so at 0 place, 1 place, 100 place, each place it will come. So here we have 1, here it will become 11, here it will become 111. So I will first calculate this thing, and next what I will do, what I told you, we have to see the left count. So for this one, left count is 2, and for right side it is also becoming 1 time. So left count plus 1. Why? Because this 1 will also be written as single one, na? 1 with 4 to 1, 1 with 2 1, and 1 with this 1 2. So what you will do, 2 plus 1 3. So 3 into val is 1 into value of 10th cumulative, so it is 1 here. Okay, then for this 2, left count is, for this 2 only we have one number in the left plus 1. So 2 into val is also 2 into 10th cumulative is 11. 11 plus for this 4, left count is 0 plus 1, so 1 into value is 4 into 10th cumulative is 111. So let's calculate this. So it will be 3, it will be 2 into 2 4, 44, plus here it is 444. So if I will add all of them, 1 9 4, it is coming 491, and yes, the answer was 491. So I hope the thing is clear. So let's write the pseudocode for this. So I will run a for loop for finding out the contribution at each place. So since it is a string, I will start from this index. So it is n minus 1 at index now. So for I is equal to n minus 1, I should be greater than equal to 0, I plus plus. I also have to see this cumulative. So instead of storing this in advance, I will calculate while going. So I will create int cumulative. In the starting it is 1, so 1 here. Okay, now what I will do, I am at this place. So what I told you, left count plus 1, and this value will be added in the answer. So I will also create my answer, which is 0 in the starting. So answer plus is equal to what? Left count. How to find out the left count? If I was at this 1th place, it is index number 0 1 2. So left count was this I value 2, and we also have to plus 1. So I plus 1 into, we have to multiply with value. So how we can find out the current value? S of I minus of 0, correct, into value of 10 cumulative. So into cumulative, correct. So this will be the contribution of this place value. After this, when I will reach to this index, my cumulative will be multiplied by 10 plus 11, because 1 into 10 plus 1, next time it will be 11. For this 11 into 10 plus 1, next time it will be 111, like this. So my cumulative will be equal to cumulative into 10 plus 1. Simple, and just written answer. So if I will talk about the time complexity of this solution, here we have solve function. There may be parameters inside this. I am just writing the pseudocode. So if I will talk about the time complexity of this solution, you can see that we are only running one for loop. So it is O of n. And since we have not used any extract space here, so it is O of 1. Let's write this code. I will create one cumulative here, which is in the starting is 1. We will run a for loop for int I is equal to -1. I should be less than equal to 0. I minus minus. My answer is answer plus is equal to what? Uh, left sum, that was left count, that was I, and 1 for the substring which will start from the current index, into value. So value of s of I minus 0 into cumulative. And now cumulative into is equal to cumulative is equal to cumulative into 10 plus 1. Correct? And in the last we have to just run the answer. Let submit its solution. Yeah, it has been successfully submitted. So thanks for watching the video. If you have any doubt, any query, any suggestion, you can write it in the comment box. Thanks for watching. Have a good day. Bye.